So we are going to see the numericals based on the Faraday's law. This is two numericals. First we will see this one. The first one, magnetic field of 10 Tesla. Please note down this numerical and then we will see how to solve it. 10 Tesla acts normal to a coil of 50 turns having 100 centimeter square area. Find EMF induced if coil is removed in 0.1 second. Yes, we will first now note down the data. So data is magnetic field is 10 Tesla. Number of turns 50. So BA cos theta, but if there are number of turns, we'll have to multiply with the number of turns. Area is already given 100 centimeter square. Convert it to SI unit, meter square. Then the time, small t, is 0.1 second. Now, it is said that EMF induced in the coil you have to find when the coil is removed in 0.1 second. Yes, so now first thing is coil is removed. So when coil is removed, there will be no flux. So phi 2 is 0. Okay, that is clear. Phi 2 is 0 as a coil is removed. Now phi 1, so initial flux phi 1 will be equal to the formula that you have to use, BA cos theta. But as there is number of turns of the coil, we will have to use N. Number of turns, NBA cos theta. Now what is theta here? Yes, that is very carefully you have to see. Normal to the coil. Okay, magnetic field is normal to the coil. It means yes 90 degrees to the surface. So see, this is the surface. This is the surface and this is then the acting to the plane of this surface. You can see here. Okay, this is acting perpendicular and area vector is also acting perpendicular. So actually normal means magnetic field and area are parallel. B and A are parallel, not 90 degree. Okay, so if this is the surface of the coil, this is perpendicular magnetic field, area vector also perpendicular. So here you can make mistake. Normally we directly consider 90 degree. No, normal to the plane of the coil. So but area is also normal. So theta will be considered as 0 degree. So now just substitute and you will find phi 1. You already have phi 2, then we will use the Faraday's law. So 50, magnetic field is 10. This will be 10 raised to minus 2. That is nothing but 5 Tesla meter square, or Weber also you can write it. So we have with us phi 1 and phi 2. Then easily we can determine the induced EMF by using the Faraday law. Phi 2 minus phi 1 upon T. This one. Okay, now I'll go to the next numerical. Yes, you have to take down this numerical. A square loop of side. The side is given, so area we'll have to find it. It's a square loop. If it is circular, accordingly you'll use the formula for area. Resistance is given because current is asked. It is placed vertical east-west plane, and now afterwards it is northeast. So accordingly you have to consider theta. East-west and northeast means 45 degrees theta. Magnetic field is given as 0.1 Tesla. This will give you phi 1. Phi 2 here again is 0 because it is decreased to 0 and time is given. Yes. So area is L square, that is 10 square, again 100 centimeters square. 10 to the power minus 4 we multiply to get a meter square. Then resistance is 0.7 ohm. Theta is 45 degrees. East to west plane. Set up across the plane northeast direction. So east west and northeast, if you consider that it's 45 degrees, then phi 2 is 0, phi 1 we will have to find, and time is 0.7 seconds. So let us find here number of turns are not given, so you have to consider one turn. So just you have to use BA cos theta. Just now substitute all the values. Yeah, magnetic field is given as 0.1 Tesla. Cos 45 1 by root 2, you can take 0.707. So then I can write it as 7.07 into 10 raised to minus 4, because this is minus 3, I have shifted one decimal. So 10 raised to minus 4 Weber. Phi 2 you already know, 0 Weber. Again same way you have to just find EMF by using phi 2 minus phi 1 by T. And for the current, okay, you have to just divide that by the resistance. That's why this resistance is given, because current is even asked. So E equals to this, I think calculation you can do, and then current is V by R, that is your E by